So as a continuation of my lecture series in control systems, we are going to discuss about block diagram reduction technique. So in the previous topics, we learnt about mechanical translational system and how to convert it into a transfer function. Whereas a rotational system and how to convert it into a transfer function. So that is a system which is converted into an equation. So this is the question will be in the presence of block diagram and how we are going to reduce it to a transfer function using some rules. So that is what is the thing that we are going to learn in this video. So before going into the topic, let us recall what is open loop and closed loop system. So open loop it is clearly shown in the picture. We will have a control unit, a driver circuit and a motor, but there is no feedback available in the open loop control system. So there we had a drawback, like what is the output that we expect, we cannot be able to extract. Whereas in closed loop control system, we will have a feedback, like we can routine the process, we can continue the process till we get the required output. So this is the difference between open loop and closed loop transfer function. So basically we have 11 rules in block diagram reduction technique. Whereas the basic rules of block diagram reduction comes under 1 to 5 and additional rules comes under 6 to 11, and let us learn about the advantages. So let us simplify the block diagram. So first we will have the components. So first we have to identify the components, simplify the block diagram, analyze the system behavior and design control strategies and implement in the control system. So here let us have rule 1, which is combining the blocks in cascade. So we all know that block diagram will be in a certain block and it will be represented in the blocks. So if two blocks are nearby and we have to combine, then we can go with rule 1, which is G1 and G2 combined will have a G1, G2. So where A multiplied by G1 gives AG1, and when we combine both also we get the same output, which is AG1, G2. Coming to rule 2, combining parallel blocks. So what we have to do if the blocks are parallel and we have the same input. So the two outputs of the blocks should be combined in a point which is called as summing point. So the output of one line and another line is added up together, and A can be taken common, which is A into G1 plus G2. So the same thing can be performed by making it as a one block, like adding two parallel blocks, which is A G1 plus G2. Coming to rule 3, moving the branch point ahead of the block. So in some problems, we will not be able to solve because 2 or 3 branch points will be in the same point, or we will not have a proper place to apply the rule. So in that time, we have to move ahead or move before. Like, so rule 3 is branch point ahead the block, which is A. So when we move ahead, we have to add 1 by G to the line branch point. Okay. So in rule 4, moving the branch point before the block, which is when we transfer a point before the block, then we have to add that value to that particular place so that we get the same output. So all these rules are applied in order to simplify the block, not to change the output. Okay, so output should not change, but we have to alter. Coming to rule 5, moving the summing point ahead of the block. So when we have to, so in the previous 2 rules, we learnt about moving the branch point, whereas here we have to move the summing point. So that time also we have to add G and 1 by G. So the output is not changing, but the block is simplified to one block. Coming to rule 7, interchanging summing points. So we have 2 summing points, then we have to interchange because it may be overlapped with another circuit. So when we move, then we can get a separate loop in order to apply the rule. So for that we have to interchange summing points. Then splitting summing points. So whereas 3 points join at one place, then that we call it as multiple summing, multiple point, which we should be separate it. So by applying rule 8, we can split the summing points. So rule 9 is combining summing points. So splitting, combining, opposite. Next one, elimination of negative feedback loop. Negative is nothing but inside the summing loop, the feedback joining place, it is mentioned as minus. That's why it is called as negative feedback loop. So if it is like this, then the general formula will be G by 1 plus GH, which is the closed loop transfer function C by R. C by R is output divided by input, whereas the formula for transfer function is Laplace transform of output by Laplace transform of input. So here output is mentioned as C and input is mentioned as R. So C by R, which is equal to G by 1 plus GH. So similar way, we have positive feedback loop. So inside the summing point C, we have a plus sign. So that's why it's called as positive feedback loop. So this is opposite to rule 10, which is G by 1 minus GH. So this is about the 11 basic rules of block diagram reduction technique in which to determine the transfer function. So let us summarize. So in this lecture, we have discussed about 5 simple basic rules, and 6 to 11 will be additional rules like summing point interchange, summing point moving before and ahead, and simplifying the feedback, which is negative feedback and positive feedback. So with this, we will see in the next video. Thank you.